All right. Uh, Let me see if I can enlarge. All right, fantastic. So, greetings everyone to all the speakers and the audience around the globe. Good morning, good afternoon, good evening to everyone. Thank you for joining us at Exchanging Ideas 31 Global 5G Evolution. We build global 5G community um, with 5G ecosystem experts around the world. And we have about 220 5G experts from 49 countries, from tier one, tier two vendors, tier one, tier two telcos, mobile network operators, vertical startups, universities, research institutes, and disruptive developers. We provide local perspective on global issues, and Global 5G Evolution is a platform and community providing a million of engineers with informative content to help them innovate in the 5G technology domain. With this global community, we have successfully organized about 30 conferences with hundreds of presentations of worldwide researchers and solutions, and we are giving it for free to everyone. But the technology is not limited with 5G. We have also covered cloud, telco cloud, AI, ML, IoT, big data, analytics, automation, open RAN, private network, fixed wireless access, hyperscalers, Edge, AR, VR, XR, metaverse, and Web 3.0, and also emerging technologies. This is an offering of global 5G evolution to the speakers and also the audience around the world. Is there any way we can collaborate with your organization for a partnership in expanding this global 5G community program? Some of the key benefits is building young talents, expanding reach outs in different communities, and possibly for more business partnerships, particularly in the startup and vertical segments. We are open for any discussions, and please feel free to buzz me, and we can able to take this up. Now, the topic for today's presentation is titled as the 5G standalone challenges. CSPs initially piloted the 5G services in their networks with the legacy 2G, 3G, 4G services. Now they are using 5G new radio and 5G core to deliver the basic 5G use cases. First for the 5G standalone SIM and then to deliver complex use cases. 5G new radio RAN and 5G core are critical enablers. CSPs have already launched 5G NSA service, which 5G data service using existing LTE networks to deliver partial 5G service where G Node B is serving 5G UEs. And the 5G UE providers are onboarding operator networks and testing the UE's capabilities for the 5G standalone, non-standalone, the 2G, 3G, and 4G networks, data and voice services, including interworking with Wi-Fi and the fixed line networks. Now, this is the 3GPP that has defined 6 architectures or options for 5G standalone and non-standalone to serve the network services to CSPs. And most CSPs use option 3, 5G new radio with an existing LTE network. And option 2 for 5G standalone, 5G new radio, and the 5G core. This 5G standalone deployment serves the network services for applications and user demand for low latency and high throughput. If we look this portion, this is a migration to 5G standalone architecture. CSPs migrate 5G services directly from an evolved packet system, the EPC, and this standalone architecture can take advantage of 5G end-to-end network capabilities supported by the new radio and the 5G core. This option makes it easy to deliver the 5G services at new sites for specific customer base, but it does not easily fulfill the integration and migration of the legacy services, right? So there's a lot of complexity that is involved that I will able to mention that in the later. Now, this is the quite interesting when it comes to the 5G standalone service benefits. Of course, in terms of creating new business opportunities, improve user experience, increase the network efficiency, cloud native and microservices, easy integration and deployment. It also saves the battery life for more than 10 years. But most importantly, 5G standalone capabilities enables the new use cases. For example, number one, in terms of the ultra low latency and higher bit rates, 5G standalone enables the super fast response times and faster access to higher data rates and are required by cloud gaming, immersive media, and vehicles or coverage control. Number two is the increased capacity and coverage. Compared to 4G, 5G dual connectivity carrier aggregator boosts the network capacity by at least 27% and brings coverage to 25% more people that use the mid-band from the downlink. And lastly, as you can see the network slicing, end-to-end network slicing with higher scalability and enhanced quality of services management enables new business models and use cases across all verticals, and it creates new revenue opportunities for CSPs. Now, these are the four key challenges here. Number one, it comes to the UE and cell coverage challenges to deploy the 5G standalone. You see, 5G UE devices and cell coverage are the most critical front end elements that need to meet performance, the stability, and latency standards. And the challenge is business and user compliance in terms of service, which must be proven in UE cell coverage with a supported 5G core network. Number two, when it comes to 5G standalone service deployment challenges, because when it comes to the integration between the 5G SA, NSA, and 4G, 3G, 2G, there is no clear service deployment and a subscriber migration strategy. And 5G network interfaces and protocols are new, and gaining the knowledge and building domain expertise makes it very difficult to validate the vendor solution, right? And the third is the network service integration challenges. Like for example, CSPs to deploy integrated solution in the network to deliver both 5G and existing 4G services. And this kind of deployment contains various challenges, including the availability of the existing 5G, NSA, 4G, 3G, the packet switch, the circuit switch services. And lastly is the service testing challenge. There are 5 service testing issues for CSP to face. Number one is covering the system integration testing. Number two is the interoperability testing. Third is the production integration testing. Fourth, the device testing. Fifth, the end-to-end testing and the stress testing. And lastly is the security testing. Now, this is a quick one that I'm going to explain. It's very straightforward and comes to the deployment approach of a 5G standalone service in a telco service provider network. And this roadmap is the phase order deployment plan in which 5G standalone subscribers have 5G SA service and interwork with the legacy EPC for 4G data and voice service. But what I want to mention clearly is we have these 5 layers, right? One from the standalone deployment towards the 4G integration, the 3G, 2G, the network stability and performance, and lastly, the integrated 5G, 4G, 3G, 2G. But what I want to stress here is the main activities that require to deploy all network service successfully is number one is all about 5G hardware and software solution in the operator lab and the production network sites. Number two is the integration of the 5G standalone solution independently to ensure 5G standalone is working successfully, to test the 5G standalone UE with provisioning subscribers and on the 5G standalone provisioning, and then followed by the integration of the 5G standalone solution with existing legacy network and provisioning to those subscribers. And fifth is to test the 4G, 3G, 2G Wi-Fi services using the 5G standalone subs, including the mobility management. And lastly is configure the network features such as the dedicated core network and network slicing to test all the services based on the customer requirements. So this is my last slide on the dot, the 10th minute. The conclusion is the journey from 4G to 5G is complex. It's not just a move to a new generation of mobile communication. Instead, it's a paradigm shift that requires new ways of understanding the design changes. And this includes the single database to store subscribe data, serve all network services, new features, low latency, higher throughput, and fault tolerance. So CSPs need to build a new strategy that focuses on using automation to test and deploy the network services very quickly. Early planning to identify the activities for automation is the best approach to save time and effort and cost in the service uh, deployment. So that's the overall of my presentation. Thank you so much. And I would like to introduce George Tesic from Serbia to present on the 5G deployment strategy. Over to you, George.
Thank you, Kanesh. First of all, I would like to thank you for inviting me to this 5G service. I appreciate it. As Kanesh mentioned, my name is George Tesic, and I'm working in Aspire Technology as a 5G subject matter expert. Today, I would like to discuss about 5G strategy deployments. So what are the options for early 5G deployment, and also what you can expect in the near future. For instance, what is mandatory for ultra reliable low latency communication? For instance, is it only needed to deploy 5G standalone, or is it needed to put also some other deployments as well in the network? So today, I would like to show you what would be the, let's say, early 5G deployments. So the main objective for sure for operators is to introduce the new technology, in this particular case, the 5G technology, as soon as possible, and to have the coverage of the technology throughout the whole country. However, there are also some older technologies like LTE, 3G, and 2G. Some of them, most of operators are performing a sunset of some technologies such as 3G, but for sure the LTE technology will remain dominant for many years. Some, let's say, natural solution in the transition phase between LTE and new radio could be the spectrum sharing between these two technologies. This kind of spectrum sharing provides the flexibility of the spectrum usage between 4G and 5G technology, and this is very important on already deployed LTE carriers. So CSP don't need to wait for the spectrum auction on mid-band or mid-wave, so they can deploy the new radio technology on already existing LTE carrier and to share the resources between these two technology in a dynamic way. When I say a dynamic way, I mean the sharing of resources can be done on a TTL level, which is in this particular case 1 milliseconds, and also in frequency domain, it can be done, let's say, on RBG level or 8 resource blocks. So there is a very high granularity between the sharing of LTE and new radio resources. Important benefit of spectrum sharing is actually to use this dynamic spectrum sharing layer together with mid-band or millimeter wave layer in a carrier aggregation combo, and to extend the coverage of mid-band and millimeter wave by shifting these control channels from these high layers to lower frequency because they have a better penetrations. So by doing that, you can extend the mid-band and millimeter wave coverage. However, at the moment, this kind of benefit in most cases is not seen with the current DSS deployment. Most of the operators are using the dynamic spectrum sharing technology to be, let's say, the first CSP in the country which have the 5G technology, and to show the, let's say, in simple words, to have the 5G icon on a device. However, if you want to deploy something on a fast premises, there will be for sure some drawbacks, and drawback of this kind of deployment is in terms of achievable maximum LTE and new radio throughputs. For instance, for bandwidth of 20 megahertz, with clean LTE carrier, you can achieve around 380 megabits per second. Once you deploy the DSS technology, your capacity of the LTE level layer will be reduced by around 10% because of the introduction of some special MBSF and subframes that are needed to transmit the reference signals and control channels to for new radio technology. And as you can see here on the bar chart, once you utilize the DSS network with more new radio users and with more new radio traffic, the cell capacity will degrade because of the transmission of both LTE and new radio reference signals in the same resource block grid. And you can expect with only new radio users on DSS cell that capacity of that cell will be degraded by around 30% from the theoretical perspective. But there is also some practical impact from cell reference signals on LTE part that might cause the high block error rate and modulation and connectivity decrease on new radios. So from the practical perspective, actually you can expect around 35 or 40% degradation in cell capacity of DSS layers. So that's why it is important to use this dynamic spectrum sharer layer in a phase where you can boost the coverage on mid-band or millimeter wave and not to use this as isolated layer, let's say, and only 5G layer. When talking about real 5G deployment options, most of the CSPs are using option 3. That's also what Ganesh mentioned. But option 3, it has also option 3X, which means that G0B, which is a 5G base station, will be the anchor point of the split bearer between LTE and 5G. So in option 3X, both LTE base station and 5G base station can work simultaneously and can additionally boost the throughputs. However, they are only connected directly to the LTE packet core. So only 1 out of 3 main use cases that 5G promises can be covered, which is the eMBB use case. Another 2 use cases, such as, for instance, ultra reliable low latency communication, can be covered with option 2, which is the standalone option, where 5G base station is directly connected to the next generation 5G core. Okay. At the moment, great majority of the 5G enabled operators are using non-standalone networking, and this can be the most sensible option for fast 5G deployment from many perspectives. From a cost perspective, because you don't need to deploy the 5G core, you can use the already existing LTE core. And also from, for instance, benchmarking purposes. For instance, if you want to test the performance in your network with a single user drive test device, then in that case, non-standalone deployment will be much better than standalone deployment, because you can use not only the 5G base station, you can use also the LTE carrier aggregation components that can additionally boost the downlink and uplink throughputs. However, as already mentioned, non-standalone deployment is limited in terms of other use cases that require a low latency. This can be, as I already mentioned, achieved by the standalone deployment. And in the transition phase between non-standalone and standalone deployment, there can be dual mode networking, which vendor provides. This is kind of hybrid networking, which usually uses the option 3X and option 2 simultaneously. So, for instance, UE1, which is a new radio standalone capable UE, can be directly connected to the standalone G0B in a standalone mode, while, for instance, UE2, which is the ENDC non-standalone capable device, can be connected at the same time on the same G0B, but work in a non-standalone mode together with E0B. This is something that will be very important in this transition phase between non-standalone and standalone networking, and to have this kind of transmission on a smooth way. However, deploying 5G standalone at the end with, for instance, similar core architecture as in LTE will not bring significant improvements in end-to-end latency performance. It will bring more improvements in terms of air interface, because you have flexibility on air interface with numerology, where you can use where actually you can shorten a transmission time interval that can be less than 1 millisecond. So you can use, for instance, 0.5 milliseconds, which is mainly used in mid-band range. because of the mini slot usage for type B transmissions. However, this will not bring a significant improvements in end-to-end latency, considering the similar architecture as the LTE we have. Key enabler for that will be a mobile edge computing that entails the computational and storage capabilities within the RAN domain. So by putting this MAC service close to the base station, the round trip time will be reduced drastically. And this can basically open doors and for some use cases such as vehicle to vehicle or augmented or virtual reality. So this is something that will bring the improvements in the latency, but not the pure, let's say, standalone with only 5G core that has basically similar architecture as the 5G core. This is more or less today from me. Thank you. I hope that you enjoyed it. And should you have any questions, please, you can ask me in the Q&A session at the end of this conference. Thank you.
Fantastic, Josh. That was a brilliant presentation. I appreciate that so much. Moving on, let me introduce Sharif Salim from Dubai, UAE, to present on the 5G metaverse. Over to you.
Thank you, Ganesh. Hi, everyone. Nice to meet you all, and it's a pleasure to present today. Let me share my screen. All right, today we are discussing an interesting topic. I believe most of the market today is hyped about what 5G metaverse can lead into and what is the impact today as an operator and how I can prepare for the evolution of metaverse. So as you can see, it all started when the concept was formalized in 2021 out of multiple stack of technologies, which I'll walk you through today. It all started with a full market cap expectation and revenue and opportunities around $148 billion in 2021. And after the evolution of different providers today in the market, from Meta, the hyperscalers, and the partnership with the operators, that hype exploded and it has a huge market cap now around 1.5 billion expectation in 2023. From a Gartner report, we are expecting that this will keep on hyping and the technology will evolve from starting of 2022, where Web3 was formalized, and goes into an advanced metaverse where IoT and digital twin will merge and the industrial use cases will be formalized. And then it will grow up to another 5 years where the maturity of the technology will evolve and the decentralization and dependencies on the operator will be a key change in the infrastructure of how we build network, how we build edge, and even how we monetize 5G, whether in the private SA or NSA, and even the 6G standards that we're trying to contribute into from the field and research, and how it can accommodate this type of technologies. Now, if you looked at the capabilities, it's actually evolving around the physical world, which is the infrastructure, the connectivity, and how we build it, and then how we link this from sensors and an IoT perspective, where you mimic the environment, you model it with GPUs and spatial computing, where hyperscalers start to get involved to give you that massive scale to build the application and mimic the entire environment exactly as a copy. And this is where you can monitor, predict, add analytics. You can track the changes across the past couple of years or hours or minutes. And basically you can predict a failure in your infrastructure and also democratize this from automation. You can even build logic to respond and interface, which is basically can interact between different teams, whether they reside as different parts of the world, and immerse this technology with all of this data in a single place of interaction, whether you feel that you're in a different universe or you create your own space in a different dimension, and you collaborate, whether it's physical or multiple different teams who can join from Zoom or Teams or WebEx, or even now creating your own avatar and joining that as if you were there. This is beautiful, good stuff, but what is the impact of that, right, in the industry? So the industries today, they are hungry for the use cases. They think that this will make a lot of cost reduction, especially of what COVID presented to us on different sectors, consumer, regardless whether it's gaming or even retail shopping, commercial, and that has impact on, as an industry from commercial perspective, and also manufacturing, oil and gas, and that basically take the innovation of Industry 4.0 as well to evolve and emerge. Where basically you can enhance the social interactions, how you shop, how you do trading across different platforms, how you do collaborations, and even like meeting families across the world. And that also put pressure in the commercial sectors to provide that technology, right? So that users will no longer need to use apps to interact with their goods and selling points, but also wants to collaborate and feel that they are part of the experience. And that, of course, put pressure to transform their technology as retailers and commercial streams in order to see how we can monetize this opportunities out of the horizon. If you looked at the industrial perspective, there's a lot of use cases, right? From predictive maintenance, even streamlined field service, interacting and collaborating in solving a problem in the field. Even field towers for telcos today, they use field service as a connected field, where basically they bring in a goggle, they bring in the previous engineer who fixed the site, and they collaborate on fixing the issue and reduce the downtime. A lot of innovations and a lot of pressure. But if you looked at it today, what are the different layers that construct the metaverse into execution? You'll see the reverse pyramid started to shape, right? A lot of throttling will happen on the infrastructure and pressure, where it becomes not just spectrum, but also optics. That's why you will see we started to explore 6G and Wi-Fi 6 beyond, and how we can build a different infrastructure, even on the radio perspective, whether it's Open RAN, and even how we structure the manufacturing of the antennas itself to accommodate such huge demand of innovation, which will come as part of each consumer and B2B segments of the market. And then that will change even how we decentralize our infrastructure from edge, how we build edge AI and IoT, not just decentralizing our UBFs or 5G SA or a slice of the network in public or private MEC or edge. And also that will require huge special computing integration from the likes of Meta as Facebook, or hyperscalers like Microsoft, Amazon, Google. You'll see that they provide that scale of the applications and the technology and the stack, the modularity of the stack, and then how we can push that to the edge, and how we can use a proper infrastructure that can accommodate this. And that all happened in 2021 after a lot of research and standards, where you will see that the edge demanded hyperscaler to meet the wireless carriers to see how they can work together, and that changed the infrastructure philosophy. Right today, if you're building a solution X, let's say it's a metaverse in this example, I will always, as an operator, will require edge as a component, 5G, and a cloud from hyperscaler to give me the ability to scale the applications and ability for us to do the GPU computing. But that also has an impact on the design of how we build the infrastructure, right? And that made the telcos hungry, right? Today, if you looked at all the telcos evolution or operators, they will look into becoming a techos, building use cases, monetizing the 5G, using the metaverse as an interface for all of these use cases. And that gives them the ability to have a Swiss Army knife, right? So I have the ability to give a solution for let's say oil and gas infrastructure. So I will have that Swiss Army knife, where I will merge my infrastructure as a telco, bring in the applications, the devices and sensors, and then provide the ability to solve business KPIs. And that's what influenced the telco transformation nowadays, from the BSS up to the radio or even at the customer interface. And if you looked at the zonal design today, we need to look, it depends of course from geography perspective, whether it's you're in Europe, US, or even Middle East and Africa or India, you will look at the horizon, it's completely different, and how we design the optimal placement of the edge in the existing network. After a lot of live experimentals, That wasn't sufficient enough, even though, to carry out an enterprise edge deployment, or even just simulating a digital twin environment, not even exposing the interface. That wasn't that sufficient. And the problem when you go into the details is basically this is a traditional operator. They focus on building the telco cloud infrastructure, try to push that across their optics or aggregation sites to give the best optimal design for 4G and 5G design. And then enterprise customer came with their own demands, right? Which added a full transformation of how we operate the radio, how we create private APNs, how we can create slicing, and how we can create those virtual cellulars where it can only be dedicated to a certain customer. And that's very difficult equation to manage when we come to designing a purely O-RAN and vRAN standards. Challenges, interoperability and multi-vendor integration is completely quite complex. And also having the enterprise to accommodate the use cases, you need to offload that part of the radio into the customer site to give you the low latency confined within the site with a proper MAC to offload all the applications, and also the 5G SA where it connect all that devices to the customer. And to provide the applications, you need also to connect to the hyperscaler. You need to figure out how I can get that MAC where hyperscaler started to build as a plug and play as a service. I don't have to invent the stack, zero touch provisioning, or it's almost plug and play, app ready with a core, with the radio as a bundle through system integrators, and you give it to the customer to solve their problem, not just solving connectivity problems, but also having a full end-to-end ecosystem. And that disperse the edge, not just for a private enterprise use cases, but also into the public, where you can target consumer metaverse, or you can target a field service where they need to connect and collaborate in a single site, and you need to backhaul the traffic to the hyperscaler. And that's another challenge, because we never expected that the amount of traffic will impact the network design. And that brought in a new concept where it requires an edge slice, not just 5G slice, but also how we can push the connectivity closer from the central regional integration of the network, but also closer to optics and closer to the customer. So you can have a single optimum backhauling to your application with almost almost 2 to 3 millisecond latency, if not even lower. And it gets
Sharif, sorry, due to the time reason, it's already over exceed. Are you able to quickly wrap it up?
Yes, I'm almost done. So that's basically, it provides the concept of B2B end-to-end partition. And that's a new standards architecture philosophy that we are working today with our customers to produce, but that basically is designed to solve that problem that metaverse will definitely create in the upcoming years. So as a conclusion, metaverse will always need 5G, if not even 6G, and we realize that as standards, and even the vice versa as an opportunity to monetize. Thank you so much, Ganesh, and thank you so much, everyone, for the opportunity.
That was brilliant, Sharif. Fantastic. Lots of information. Thank you so much. I really appreciate you. Now, let me introduce Samir Taroy from Paris, France, to present on the 5G telco cloud. Over to you, Samir.
Hello, everyone. Thank you very much for this invitation. So today we'll talk about how 5G and telco cloud are merged to deploy telecom infrastructures in minutes. So let me share my screen. Okay. So I'm Samir. I am the founder and co-founder and CEO of LabLabby. LabLabby is the first worldwide hands-on platform in telecom and cloud solutions. So today we are talking about a lot of technologies as we are living in this market, a big paradigm shift. We are moving from telecom to telco cloud, and there is a lot of technologies impacted, and one of them is 5G. But also It's same with IoT, even 4G. Many operators in the world, they are deploying 4G in telco cloud solutions, and also other solutions like OpenRun, because OpenRun is based on microservices, and microservices based on pods in Kubernetes clusters. So the problem in general, when we are talking about a paradigm shifts and new technologies, there is directly an impact on skills. And what we observe that there is a lot of technologies, there is a lot of solutions, and no one is talking about how to upskill and reskill people in this kind of technologies. And here we come. So this problem is not just for operators, telco operators, but we are talking about a lot about Industry 4.0. So it's impacting all the automotive, IoTs platform manufacturers like energy companies, oil and gas companies, transportation companies, and also consulting companies, because consulting, they are working for operators and this kind of industrials, training centers, schools and universities. So there is a huge use cases, and each one is representing a lot of tech people coming from research development, from engineering, operations, support and maintenance. So how to be operational ready and what is the cost? So yeah, today let's talk about expertises. So the problem, if you want to deploy a lab, and I will show you like a real example after, a practical example. So if you want to deploy a lab, like any kind of labs, you have to buy very expensive hardware. You have to add cost of deployment, installation, support and maintenance. And after deploying this lab, you have to add some cost of support. So what we did with LabLab, so the hardware is free, everything in this cloud, and I will show you how we are deploying today a lot of labs in minutes, and there is no installation. So everything is automated. We have our own orchestrator deploying multiple type of technologies in telco cloud platform. So yeah, today, if you want labs, you can use legacy vendor solutions, or you can, if you want like just focusing on theory to get the skills, there is a lot of platform providing this. And there is also a lot of platform providing virtual labs, but they are focusing on other verticals like cybersecurity or IT. I'm thinking about Cloud Guru, for example, or Hack the Box, like one of the biggest platform in cybersecurity. But there is no platform providing the same thing in telco cloud and in general in telco. So it's why we created LabLab. So let's imagine what is LabLab, and after I will go directly to a practical use case. So this is a 5G architecture, starting from G-Node B, the radio part UE. And after you have all the core network from IMF, SMF, and all interfaces and the protocols. So we provide the same architecture, the same end-to-end architecture with all the interface, all the protocols in minutes. So this is the idea. Adding to this, we have a SaaS platform. So is why we are talking about SaaS in telecom, because all these kind of technologies, it can be IoT, it can be OpenRun, it can be all technologies needed in this market are deployed in the same way. So see it as Netflix, instead to have movies and then series, you have labs of telco and telco cloud technologies. So yeah, it's unlimited labs. So we are not just focusing in 5G, but today I will showcase the 5G use case. But we are doing this with 4G, with OpenStack, with all kinds of technologies related to telco cloud. So how it's working? So this is the end-to-end architecture, high level. So we have the users, they have some credentials. So and they connect as you are connecting to any platform. So with the user and password. This platform is a SaaS platform connected through an API to an orchestrator, which is LabLab CI/CD platform. And this platform is connected to many cloud providers. It's agnostic. We are doing any cloud. So we are deploying 5G in Amazon, we are deploying 5G in OVH, in Azure, any kind of technologies. So the orchestrator can deploy in minutes, can remove in minutes, and they can also do scaling and scale outs. So this is the use cases, most use cases present in the market. And today we can also do healing if you want to upgrade some software, and also it's auto healing and also upgrades. So today even upgrades is automated in our platform. So all use cases, all the life cycle to have a 5G network in your production or in lab environments is automated through our platform. So let me explain you in real world, so how it's working, okay? So as we are talking, and my purpose is to show you how we can do 5G telco cloud, and this is in a lab environment. So see, this is the 5G, okay? This is 5G architecture. The UE, G-Node B, UPF, UPF connected to internet, and all other, like if you want to do some voice, you can connect to IMS, because for IMS is still present in 5G to do voice over NR. So, and you have all the core network. So it's the whole end-to-end architecture. And in this whole end-to-end architecture, you can do you can generate protocols like PFCP, which is equivalent to OpenFlow to have some SDN use cases. You can do NGAP, NAS, HTTP2, which is the major protocol in 5G to do all call flows and managing all the nodes in the core network. So, and also you can do some real use cases like how to register to a 5G network, how the handover is working, how the service request, how the paging, the registrations, all the use cases that a end user in the real live network is living, okay? So let me show you related to telco cloud. So this is the lab, okay? This is the architecture. So imagine I want to connect. I have just to click and connect, okay? So after I click in 5G nodes, I click Open Web Terminal, okay? And my whole 5G, this is the whole 5G, this is the architecture. The whole 5G end-to-end network is present. And it's about just seconds to make it present. So it's for us is wonderful because you can provide it at scale. So it's not shared lab. The problem that we are facing in the telco world, we have a lot of shared labs, and you know the issue with shared labs. If one user impacts and creates errors, it will generate many problems for other users because it's shared lab. Here, one user equal to one lab is like you have your own 5G network, your own operators, and it's same for 4G, IMS, IoT, any kind of technologies. So just I wanted to show you some, to show you that is real. So for example, you are seeing here that all the nodes, we are using, as we believe a lot in open source. So we are using a lot of open source projects in the markets. So reflecting the 3GPP protocols. So you see it's running. And imagine now, I want to do a registration. So to do registration is very easy. So we have just, I don't have the time to do all the use cases, but I want just to show you. So how to do a registration is very easy in the platform. So yeah, we have just to click here, okay? So 5G app, okay? And G-Node B down. Let me do it from here, it will be easier. Okay. And you down after this, let me open a new terminal so we can have a lot of terminals. Okay, perfect. And now I will open a new one, okay. This is the idea, just to have a traces, okay? So by the way, I did it just before I can directly show you the traces because I know we don't have a lot of time. And after I will be very happy to explain you how we did it. So this is registration in 5G, okay? So this is the traces. I don't know if you are seeing my screen, but I will share all my whole screen. It will be better, okay? Okay, so SCTP. So you see, so it's starting from connection in SCTP because you have to do the inits, and after you have the init ACK, and after, let's say just to show you. So for example, HTTP2 UC. So all like, for example, to get, you know, the first time you have to contact the NRF, which is like a repository, and all the nodes of 5G core network are present in NRF. So this is the gets, and after you have 200 OK. So just to show you that is real traces that you can analyze, you can see the headers, you can understand by practice. So, and the idea of using telco cloud, you know, there is a lot of telco cloud solutions today in the markets, but our purpose is how to showcase quickly deep use cases, like how to deploy 5G in seconds or minutes, how to do it with IoT, how to have some, because we have some network slicing use cases also. And the same, we have it in Open RAN. So if you want, like, I can give you, I think I have 2 minutes. So this is
Samir, I think the time is over. I think I have.
Okay,
sorry. I have to stop you. But
yeah.
I would love to invite you for a separate one-to-one session on a Facebook. I think this is fantastic. You have a fabulous stuff here, great stuff. Yeah, definitely we will arrange another session one-to-one, so that you know this will be helpful. Thank you so much, Samir.
Thank you.
I really appreciate it. Let's move on to the next speaker. Let me introduce Professor Dr. Jumo Maizi from Johannesburg, South Africa, to present on the 5G business models. Over to you, Dr. Jumo.
I think, Mr. You are in mute.
Can you unmute yourself, Doctor? Doctor, I can't hear you. Just unmute yourself.
Okay, can you hear me now?
Yes, sir.
Oh, my apologies for that. Let me reshare my slides again. Okay, I hope you can see the slides and you can hear me clearly now.
Yes.
Okay, yeah, apologies again for that. So my name is Mjumo Mzecha. I'm with Wits Business School, and I'm going to be presenting on 5G business models. So in terms of my background, I'm an engineer. I've been working on wireless communications for more than 20 years. My PhD was on evolved 2G into 3G wireless communication systems. Now I do research at the intersection of engineering and business. Hence my interest in 5G business models. So let me just remind you about this. I'm sure you've seen this chart many times. The key point I want to bring out here is that this is very much a supply-centered view of the 5G world. So in other words, this is what technology providers, mobile operators, standards creators, and others believe they will supply in terms of 5G. However, I think it's important for us to take a demand-centered view and look at it more from the benefits and the value that is being provided to customers. And that's where the business models and business model innovation perspective comes in. So just two very quick definitions of business models and business model innovations. These are taken from Alan Afua's book. He's a renowned scholar in this area. So this is Professor Afua's definition of a business model. So it's all of the activities that the organization does to generate, deliver, and monetize benefits to customers. And these benefits, of course, are embodied in products and services. And if that is true, then it means that a business model innovation is when you do any of those things in new ways, in novel ways. Okay, so this then suggests that there are four categories of business model innovation. So very quickly, first one is around how we generate customer benefits. So if we take a classic example from the mobile industry, rather than operators or technology providers like Google and Apple having to think of all the kinds of applications that may be useful to customers, this has now been opened up through the means of the Google Play Store, the Apple App Store, so that third parties can come in and help to generate these benefits. Second category is around delivery of customer benefits. So if we're innovating here, a good example there would be Apple's retail stores, sales and support model versus doing this through third-party distribution, other retail stores and so on. Third category is monetization of customer benefits. So how is the value monetized and how do actors like mobile network operators capture some of that value? The best example here in the mobile industry is prepaid billing. So this is what really accounts for the success of mobile. Without prepaid billing, we would not have had the enormous impact that mobile has had over the last decade or so, or more, actually 2 decades. And then the fourth category is around building and using organizational resources to produce value, to produce these customers for benefits. And these are in various subcategories. It could be around coordination mechanisms, how human resources are used, relationships between the various actors, how resources are mobilized, and so on. So an example here from the mobile industry would be MVNOs in previous generations of mobile, and I believe these will be increasingly important in 5G and beyond 5G systems as well. So some recently published research that I've been involved in. So this is from a book that was published last year called Enabling Technologies for Next Generation Wireless Communications. It's an edited volume. I wrote the second chapter in the book, which talked about the relationship between enabling technologies on the one hand and enabling business models on the other hand for 5G and beyond 5G wireless systems. And I'll be happy to share this with anyone who's interested. And then another one that was published this year, more recently in September, was a survey article that was published in IEEE Access by myself and 2 co-authors, where we were looking at 5G business models for mobile network operators in particular. I don't have time to go into all the details of this, but let me just give a flavor of what's in this work that we've done. This is from the book chapter. So it shows an integrated framework for thinking about enabling technologies and enabling business models for 5G and beyond 5G networks. And so if we go clockwise, you can think of this in terms of how the technologies are created, the architecture and the modularity of those technologies. Technology S-curves and technology cycles are somewhat related, but there is an important distinction. So the S-curve, technology S-curves talk about how, or refer to how technologies are developed over time and the different actors that are involved and how over time, eventually this produces diminishing returns, and then you need to move on to a new technology or reconfigure that technology in some way in order to embark on a new technology S-curve. Technology cycles are to do with the patterns within the industry. So for example, the notion of dominant designs is a very important one. What this is saying is that very often the winning technology, if we may call it that, is not just related to technological characteristics, but maybe related to other things that eventually make that technology dominant. Then there's also the issue of standardization and the profitability and so on. And then there's various emerging challenges. This is from the IEEE Access paper. I don't have time to go through all of these, but I can share the paper with anyone who's interested. And IEEE Access is an open journal, actually. You can also just Google the article and get it directly from the journal. Okay, so just to conclude then, business models and business model innovation are critical to the success of 5G. It's not just all about technology. We need to think in tandem about the business models and how to innovate those business models around this. The interplay between the enabling technologies and the business models themselves is very important. And I would like to suggest that this is an extremely fruitful area for ongoing research, development, and innovation for those that are in the industry, those that are in academia and research like myself and everyone else. These are my contact details. You're welcome to email me or reach out on LinkedIn or Twitter, and I'll be happy to share this research or even discuss collaboration with any of those that might be interested. Okay, I think Kanesh, I'll stop there. Thank you very much.
Thank you, Dr. Jumo. Excellent. Thank you so much. I really appreciate for your contribution. Now, moving on, let me introduce Carl Davies Barrett from Munich, Germany, to present on the title of 5G Edge and Cloud. Over to you, Carl.
Hi, everyone, and it's a pleasure to be here. My name is Carl Davies Barrett. I work at Microsoft as a cloud solution architect. The part of the organization I work in is called the Partner Success Team. And I'm very much responsible for helping our partners go to market with solutions. And so the sessions I heard today were extremely interesting, whether it's a metaverse use case or you have a BMI model that shows that 5G is the way to launch a new product. I want to take you through a GTM story, so a go-to-market story of what I encounter when I bring my partners through this 5G world that Microsoft is embracing. Microsoft has made numerous acquisitions. Metaswitch, a firm, we're working with AT&T. And you may be hearing about, private MEC coming from Azure. And, if you were interested in this, there are many sessions you can go and learn. But in essence, it frames what a partner has to build on to build their solution. So a partner coming and offering a private 5G use case in a factory will probably say, well, I need some radios and I need a RAN and I need some, some antennas. I also need some local compute. And then I'm going to need some network functions. And then I'm going to need to bring an application. And then somehow I need to orchestrate all of that. So what we do is we provide a reference architecture, which allows you to go from months to minutes in standing this up. Kind of like Ladlabi mentioned, it's great to have a place where you can experiment with a low cost and bring things up. But we need to go beyond that. We're looking at partners building private 5G as a service solutions. And whether they are SaaS-based models, whatever the delivery model is, there's a lot of infrastructure as code and a lot of orchestration that needs to happen. So when I talk to my partners, very often the large telcos, they're looking at the hardware compute platform and saying, well, what do we do? Do we go with a first-party solution or do we go with a third-party solution? And we have, a 1U box, which allows you to stand up a 5G core with the UPF running locally and a bunch of other services, as you'll see later on. But then they need to bring some edge functions. And we have a network function manager, which will allow you to bring things like a 5G core, an SD-WAN from VeloCloud, for example, or bringing some NetFoundry appliances. And that's great to get some of the connectivity up. But then you also need to run some infrastructure as code in order to bring the edge application to life. And all of that should hopefully be orchestrated through the cloud. So partners are wrapping themselves around this cloud agnostic way of doing things. And so with a hybrid approach, bringing this to the edge, as Sharif said, in order to enable metaverse, you need to be able to write things once and run them anywhere. And so what's great about a platform is if you can actually have an abstraction, a declarative way of doing things, then you should be able to write a piece of code, a Terraform script, which wherever you're deploying it, will talk to the underlying infrastructure and deploy that in an independent way. So it gets interesting for operators when they see a 5G packet core. This could be a Microsoft packet core from a firm called Metaswitch, or this could be a Soluna packet core. that's not the point of this discussion, right? All of the components are there, internetworking functions, whether you're building a standalone 5G network, you need some use case to drive the network's utilization. And that is where the MEC component comes in. The MEC, or the multi-access edge compute application, is what's doing the inference. It's gathering the RTSP feed from a video camera connected to the network, and then analyzing that data and making decisions. So the operator or the GSI, in the case of a GSI, they have that solution, right? They've built video analytics solutions, and they're looking to extend themselves into the 5G space. And if you look at an operator, they've been doing connectivity for years, and they're looking to become a value-added service provider with some kind of use case on top. So you're already seeing two components coming together nicely: the GSI, or the global system integrator, and the actual operator trying to transform itself into a techco. And on the back of this is the hyperscaler. In this case, it's Azure, with all of the services that you would expect from a securely connected environment up to the cloud, where you can do later on model training, analysis, big data, data lakes, whatnot. So the actual architecture, when you build something, this is typically what I would build for my customers and partners. You know, you've got the customer premises where you're deploying a unit. And in this case, it's an Azure Stack Edge. It could be an HCI or a hyper-converged unit. And running on that, you want to run in a disconnected fashion some low latency compute, which is gathering information and then crunching it in order to make some decisions. You'll be able to run a Kubernetes service. So, you know, the emphasis is on open source, and also the emphasis is on, you know, running things in serverless environments, but also having that kind of storage place in order to, you know, retain that video footage or those keyframes. But the key is bringing a containerized MEC application. And of course, you can use the local compute from NVIDIA and the GPUs, which are there to do spatial analysis. What you can also do is you can bring down cognitive services from Azure, or you can bring your own YOLO models, right? So if you have a data scientist, you can bring those containerized models and run those on the edge in a very kind of open manner. You're not locked into any Microsoft kind of proprietary terminology here. This is Kubernetes running at the end of the day. And of course, you may want to kind of do some stream analytics or some Kafka-like type of processing, and then push all of that data to the cloud for later on analysis and retrieval. What's important, however, is, at least to our operators, is how they can work in a disconnected fashion. So bringing that 5G core to the edge, bringing the workload to the edge, and not having that dependency on the public cloud. And of course, we look at things like having a read-only connected registry or a data gateway, which allows you to store things on the edge and keep things in a very, very hybrid and easily to control manner. So the use cases we tend to see, at least from the GSIs and the operators I'm working with, video analytics is the key one at the moment, whether it's retail and how long you spend in a queue, whether it's looking for a parking space, checking that nobody is trespassing, or making sure that people are safe at work. The video analytics use case is there. Now, again, we have a lot of ISVs which can bring those solutions. And, you know, I help partners build those solutions. I also help partners train their own models. And what's great about it is it's just plug in and plug and play. So you're already starting to see 3 parties actually taking place in this 5G rollout of an offer. And you know, whether you're looking at an SMB market or an enterprise market, there's a value proposition to be made by the 3 units coming together. It's very often a telco provider, unless you're in Germany and you can obtain some private spectrum. You need a hyperscaler in order to bring, you know, that data and AI experience. And you also need a global partner ecosystem in order to bring some of that domain expertise. So on the left-hand side, you can see the operator is moving up the stack from the connectivity, which they were typically doing, providing SIMs, RAN, spectrum. Now they're looking at giving end-to-end managed services and looking after the billing. They're writing the APIs into the underlying hardware ordering. They're writing the APIs into the deployment. They're spending a lot of time in infrastructure as code using REST APIs with our platform in order to integrate that experience. So you can end up with a shop front which says, I want to buy a metaverse experience. I want to click on this button inside a store, and I want to be able to ship out all of the components, the glasses, the models, all of that hardware into a customer experience. And of course, they're working with the GSIs, because very often the operators don't have the expertise in a lot of the AI algorithms, which are outside of their network, but into processing business problems. They're working with the GSIs to bring that solution. And sometimes they're working with an ISV as well. And hopefully what they're doing is they're working on top of a platform, such as Microsoft's platform, to bring either that ecosystem, to bring that device connectivity, to bring that 5G core as a service, and also to bring all of that through APIs. So in the process of building up their offers, most partners come to us and they say, well, how long will it take to build this 5G setup to proof of concept it with one of my customers? And typically this is a timeline we share. You're very often obtaining a RAN and getting some spectrum. Telcos are very good at doing that, and they can work with some providers like Airspan. Then they're very often looking at SIM fulfillment and selecting a use case that they want to work with. Again, we've worked with partners like IDEMIA and Contour to be able to do this SIM fulfillment. They need to get some hardware. They can order that from Microsoft as a service. So the great thing is, you click on a button, you borrow the hardware, you run the POP, you spend X amount of dollars per month, and then you send it back when you're done. You deploy the 5G core from the network function manager. Again, it's a simple set of clicks, and after 1 or 2 hours, you have a 5G core up and running on Kubernetes with all of the APIs. And then you bring your use case. You bring a camera, you bring some footage, you bring a model, and you've run your POP within a couple of weeks. So I hope this was an interesting session when it comes to what you can do with a hyperscaler partner. The partner success team is here to help any operator or any GSI looking to go to market. I'm a telco architect, so I'm interested in building those architectures, looking at the bills of materials, working with the APIs. And please do reach out to us if you're interested in taking 5G for a spin in a very cost-effective manner, and hopefully taking that to market as your new product. Thanks.
This is fabulous. Fantastic. Thank you so much. Brilliant. Let's do keep in touch. So moving on to the next speaker, let me introduce Dr. Ina Khmelnitskaya from London, UK, to present on 5G for remote medical education and in telemedicine. Over to you, Dr. Ina.
So, thank you very much, dear colleagues, for opportunity to join this conference, and I'm glad to share my real experience work with 5G.
Dr. Ina, I can't hear you well. Is it only me? I can't hear you well, yeah.
Are you hearing me not good?
Yeah, I think you got to be louder so that... Anyone else have issues to listen the speech?
Yes.
I can hear her, but the quality is not very good.
Mic is not doing some kind of...
Yeah, please proceed, Dr. Ina.
Yeah. So let me start with the main problem which concern medical education, and so it's problem again. So I apologize. So let me start with some very important problems in medicine and medical education that concern to use a very new approach with XR and 5G. So main problems, it's lack of doctors, long time waiting for patient, and very long time for preparing experienced professional. It's normally depends 10 or 20 years, and of course high price of resource for education. So we create platform, Exam Doctor, it's a medical education metaverse platform. We work on it a few years. It's around more than 4 years. And last year, we started work with 5G in some cases. So here you can see photos of using our platform, XR Doctor platform in a real world. It's a medical education, it's medicine, normal medicine, and telemedicine too. So 1 year ago, we started with 5G, and I must say that main difference use XR without 5G and with 5G, it's fast and quality. So 5G indeed opened a lot of new opportunity for using XR. So for example, you can use XR and create really new things, hologram for medicine, medical education, etc. But sometimes, it's often, you are very limited in your possibility by internet. So 5G, it's must-have. I think it's must-have for using XR in a real, not a pivot case, but in a real world in education and in telemedicine. So what is exactly help using XR in medical education? So you can see it's a blue or show how it is efficient of medical education using XR. So we most work with AR, and we know that students much more convenience to act after training. They much more focus in comparison with your students. They much more faster in the classroom training, and they much more emotionally involved education, and much more emotionally connect with each other. So what exactly XR possibilities in education using 5G? So I start with very important things. It's a live stream from, for example, surgery room or master class, and many people can see what's going on in surgery room. It's a very, very important. It's a bigger problem in medical, exactly, surgery education. So the second one, it's using AR/VR glasses, and it's not only conferences, etc. So the third one, it's a user library of programs of different clinical case. So now it's a big problem to share knowledge about clinical case in education. But usually it's possible in the mind of professors or experienced doctors, and it's quite difficult to share. We also can use not only knowledge, but we can master skills. It's very, very important, because now you can have very limited access to master skills before you are going to activation room. So this training can be individual, maybe. Outcomes when using optical. Skills in with the different models in different situation, and simulate any surgical inventors. So, and perform rare and complex surgical inventors, and very important in training new technology that doesn't use in medicine, but you can train before it started using in medicine. So if you can speak about remote education result, especially with PETG, so it's a main possibility. The first one, it's unlimited access to hologram library of damaged bones, organ implants, surgical instruments, anatomy, etc. And of course, complex and typical clinical studies through personal account on the our platform and using AR/VR glasses. The second one, it's a surgery simulation on a digital patient. You will see it later. The planning surgery, testing, practicing skill from any place in the world with internet, individually and without time limit. So, and training can take place in a convenient for the user mode without a teacher, unlimited amount of time until the materials is fully learned. It's very, very important. So the next two slides show why AR/VR training and using AR/VR in surgery much more better than using ordinary equipment. So the main things, it's using AR/VR and haptic, it's much more faster, much more cheaper, and much more comfortable. So let me move to the telemedicine. So our main experience in traumatology, so we made a lot of different real surgeries. Main it's traumatology, but we have experience with dentist, plastic, and maxillofacial surgery too. So telemedicine, it's a very new approach, very new way to use XR and use PETG with XR. So let me start with telesurgery. So you can see on the screen that two doctors which in a very different location in the USA can work together with the same hologram, and they see completely the same things as a different doctor. So it's allows to work in much more higher level. So from my experience working with a doctor, a lot of them are saying that it's a big, complex to work remote during the telesurgery. So, for example, if it's young doctors, they need a lot of consultation with other doctors and help from experienced doctors. And if they can help with, if they can use this help during the surgery, it's much more better for patient and for young doctor too. And the very new things using XR for teleconsultation. So as you can see, on the screen, it's a photo from our work. Then one doctor worked in London, another one, it's a consultant looking how doing consultations, the main doctor in London, it's USA, and the student work in Paris. So they work together at the same time, and without 5G, they can work too, but this is not so good for consultant and for student, because they have at least 30 seconds in a gap between live stream, so they can't to see and hear exactly the same what's going on in real consultation. So how doctor can use with each other? It could be a remote consultation between doctors. A single or multidisciplinary consultation can be held in a complex cases regardless of the geographical location of the event participation. The participate of the telemedicine consultation must have access to the internet, AR or VR, better AR glasses, and access to the personal account. And each doctor has access to the patient hologram and the ability to manipulate it with all necessary tools as a main doctor usually in our XR-Doctor application. So now it's
Dr. Ina, I think the time is over. Would you be able to quickly wrap it up?
Okay, so now I show you that it's a photo from our application. You can see how it's really work remote education. So this screen show photos from video from class. The student work in the class with a professor. So other students joined the first group and they located in the operation room and the simulation laboratories. Also, you can join, it's a very new thing. You can join from any place in the world. It's outside or even your favorite cafe. And the more important, it's working from home. You can work with any instrument, simulate surgery at home. Or by your own, or you work together in group. So, and I said before, so the main things when you use 5G for medical education and medicine, you can scale real clinical case. You can significantly reduce the training cost, and it's an individual or collaborative with a big presence in the classes. So, and different when you use 5G and don't use 5G, it's a main that quality. You can download your model, but it will be very bad quality and very slowly. But as you use 5G, this is very fast. It's, for example, gap, what I said before, became from 30 seconds up to few milliseconds, and your eyes doesn't see it. So from our experience, 5G, it's a must-have things for using remote education and telemedicine as a real instrument in work, not only as a, just innovation, technology, or so thank you very much. And here are my contacts, and I welcome to my LinkedIn, my site, and I will open to any communication and discussion. So thank you very much.
Thank you, Dr. Ina. Great stuff. Lots of insights, information. It will be really good and beneficial for everyone. Thank you so much. I appreciate that. Now, let me introduce Cristina Marquez from Madrid, Spain, to present on 5G, IoT, and machine learning in vertical industries. Over to you, Cristina.
Thank you so much for the introduction. Good morning, everyone. My name is Cristina Marquez, and well, I'm gonna just share the screen. Please do let me know if you can see. 1 second. There we go. All right, so now it should be there. Everything's working?
Yes, I can see that.
Perfect, thank you so much. So as you said, I'm from Singular. It's a company where we basically are present everywhere in the world. I work in the Department of Data, Artificial Intelligence, and IoT as a lead of Advanced Analytics. Previously, I studied a PhD that mixed both 5G and artificial intelligence. I visited MIT, and I became the youngest next generation of the Internet Explorer by the European Commission initiative called NGI. My past as a researcher and entrepreneur allows me to work as a digital advisor, and I'm also passionate about promoting STEAM talent. So thank you for having me. I hope I can inspire more people and increase women representativity in the future. But enough of me. You have there all my contact information. Let's talk about the vertical industries. We're a company that we go where it is needed, basically. And because of that, we are in different industries. Since the topic of my presentation is about vertical market integration, I just wanted to show you some of them that we work together with. And let's go into the details. 5G will provide the necessary connectivity conditions for communication between machines, people, and objects that will allow different vertical markets to be promoted. 5G together with IoT and machine learning, or as I would say, artificial intelligence, due to the range that covers more applications, will do the task and help to improve our society. A lot of people is talking about metaverse now, as we have said before, but I think it's going to take longer to reach that step, and that some of the things that we are needed to talk and see today are covered more or less in this picture, because in the framework of Industries 4.0, there are many usages of all these technologies together, and let's explore some of them. I think it's going to be a high-level presentation, but I will go deeper into the details later. So here I just saw, for example, factories of the future where the robots' movement and sensors are all coordinated and synchronized with, for example, the supply chain and the people that are around, so no accident happen. Also, we could see in the e-health sector, the application in pills, these pill cams that will communicate with their camera with another device remotely. We could even have surgery remotely with the proper communications and applications, of course. Machine learning will allow to balance the power better between the energetic grid or even in the mobile data traffic. I can assure you that because my PhD was about this data traffic study that balance the traffic and how should I slice the network and everything so it is more efficient. Also to reduce the latency and see the trade-off between all the conditions that affects the users and the operators to provide the service. But also to allocate the resources according to the user consumption and forecast the traffic that they are gonna ingest into the network. And this would be pretty much the same in every vertical, because also in the automotive sector where cars are involved, we will have this machine-to-machine communication between cars. And this traffic will also be ingested in the network. So in the end, of course, I cannot forget about the entertainment area, where a lot of the traffic is ingested now with gamers, streaming services, as we are doing now, etc. So in the end, everything is going to be affected. I would like also to point out about mobile edge computing, because these devices, the IoT, at farms, at shops, will be processing the data before injecting them into the network. And then this will make the network more efficient. And in the end, 5G is going to affect all the areas that we know right now, from the public transportation to the automatization of buildings, the industrial production, e-health, smart cities, everything. So it will be paramount to understand how it works and how it will affect the network in the end. And in this regard, I just wanted to show a couple of examples more visually, because yeah, we are gonna use for sure virtual reality for gaming, but also for surgery. As I said, it is already in some museums, as I can assure you, because I was working at 5G Tours project in Europe. And well, also managing network slices with different requirements is challenging, but doable, I can assure you that. And of course, the XR will be present for the motor industry and even remote driving. You know, all the possibilities are there. And well, now going into the details deeply, and also my thesis, this is part of it, published at MIT OpenCourseware website. You can check it out later if you want. But basically, all these services and all these applications are going to be in the same network, right? And these services have different requirements. So if a user wants to play games while watching and streaming on the back side of the room, they will require a software-defined network and also network function virtualization, all of them orchestrated and working together. And this will be possible in 5G and 6G networks, combining them with artificial intelligence. Here, I just wanted to picture the difficulty of having all these applications together, because they are pretty much opposite when we are talking about the triangle. And this, of course, will make add complexity to the algorithms that will work with them, and of course make the network go slower and ask for more requirements. But in 5G and 6G, that would not be the case. Why? Because we will have one of the techniques that is called network slicing, and network slicing basically will categorize these applications in regard and taking into consideration all the requirements that they have, and because, for example, one of them will be latency, another one will be quality of service. All of them will be in a slice, a segment of the network categorized due to those requirements, and then the service allocated and all the resources allocated to them will be according to that slice that could be defined, redefined, reconfigurable over the time. There are much more details that affect, of course, but we don't have time to cover that. So I just wanted to show a sneak peek of the publications of my thesis. Here it is a part of it where, for example, we were balancing the traffic of the network so that all the antennas more or less have the same imbalance of traffic. And then we just did different segments, clusters of the antennas, as if they were data centers to serve all those areas. And well, in this case, we were comparing a large metropolis in Europe and a medium-sized city, and all those partitions from L1 to L12 were the different areas, clusters that we were considering. And also we were taking into account the edge with the antennas individually. And as I said, this is just an example of the multiplexing efficiency that we could have with this normalized traffic demand. Then we made a little bit more and crazy experiments, because we did consider the time window, but also the volume and also an overbooking factor. So you could forecast and reserve the resources for a user. I encourage you to check that out. And before finishing, I wanted to make a remark that is, don't forget about the security and the quality of services, because that's going to be paramount for users, and especially in medicine will be critical, as well as taking into account the NIST infrastructure for cybersecurity, where it's not only identifying and protect and detect the threats, but also respond and recover. And for recovering, where time is involved, 5G will be much helpful in the future. So before leaving, I wanted to show you my ways of contact. And also from my side, I'm from Singular. Thank you for having me, for having us here. And we look for talent everywhere. So if you want to join us, please contact us. Thank you so much. Back to you.
Thank you, Dr. Krishna Marquez. My apology, yeah. I think during the introduction, I missed out to address you as doctor. So
no problem.
Apologies. Thank you so much. It was brilliant. I really appreciate that. So now moving on to the next speaker, let me introduce Kimberly Parsons-Trommler from Germany to present the topic on looking beyond 5G. What can we expect in 6G? Over to you, Kimberly.
Yeah, thank you so much. Can everyone hear me okay?
Yes.
Okay, and you can see the slides?
Yes.
Okay, perfect. Then first of all, thank you for the invitation to speak today. We've just heard a lot about 5G, and now we're going to take a quick look at what we expect to see in 6G. My name is Kimberly Trommler. I'm the head of ThinkNet 6G, which is in Bavaria, Germany. Before we dive into 6G, just one slide about ThinkNet 6G, so you know who's presenting to you today. ThinkNet 6G is a think tank and a network community for 6G stakeholders worldwide, and anyone who's interested is welcome to participate. We were founded by and are funded by the Bavarian Ministry of Economic Affairs. Bavaria is a state in southern Germany, and if you're thinking Oktoberfest and Lederhosen right now, yes, it's that, Bavaria. We're part of Bayern Innovativ, or Bavaria Innovation, which is the innovation agency for the state of Bavaria. As such, we are not a research institute, and we're not a company that sells products or services. We're here to support companies who are interested in 6G and to act as a central point of contact and point of information. Our goals are to stimulate networking and exchange and to enable collaboration, not only in Bavaria, but also in the rest of Germany and with the rest of the world, which is one reason I'm really pleased to be here today. We have a strong focus on knowledge transfer from research into industry or from large enterprises into smaller companies. And we support pre-competitive consensus building, which is the phase that 6G is in right now. So enough about ThinkNet 6G, let's move on to 6G. And one of the first questions I usually get when I start talking about 6G is, why are you looking at 6G? We don't even have 5G yet. But it's not an either or question. We're at the beginning of 5G right now, and there's still lots more to come. However, it takes roughly 10 years to develop the next generation. And since we expect the first 6G rollouts roughly in 2030, then it's already time to start looking at 6G now. And research for 6G has already begun around the world. So the base for what 6G will eventually become is being laid right now. Like I said, we expect the first commercial deployments roughly in 2030, but how did we get that estimate? If we look first at the frequency question, frequencies for 6G will first be discussed at the World Radio Conference in 2023, but they won't be decided until the following World Radio Conference, which is in 2027. So we're looking at 2027 at the earliest for worldwide consensus on what frequencies we'll use for 6G. In parallel to the frequencies question, we also need to look at the 3GPP standards releases. And when we look at 3GPP, the picture is much less defined. Currently, 3GPP says that release 18 will still be a 5G release. And they're currently calling release 18 and everything beyond that 5G advanced. They are very carefully avoiding the term 6G. Now, their formal work schedule doesn't really go much past 2024 at the moment. So it's simply too early to say what release will end up being the first 6G release or when that release will appear. But industry expects it to be roughly 2027, 2028, probably release 21. But like I said, 3GPP themselves are not making any statements about 6G or the releases for 6G yet. So what are some of the use cases we expect to see for 6G? What is the killer app going to be? Now, we expect 6G to focus on the interaction between humans, the physical world, and digital worlds. So the interaction between humans with other humans, between humans and the real world around us, and between humans and digital worlds like extended reality or metaverse. Realistically, the killer app for 6G will probably end up being something we can't even imagine today. But if we look at what we can imagine today, because that's all we can look at the moment, there are groups of applications that stand out. This particular diagram is from the Hexa-X project, which is the European Union flagship 6G research project. And I can't go into all of these in detail. I'll just look at one, telepresence. So one vision here is to enable full holographic telepresence in real time. So when you're on a video call, instead of a 2D video like today, you would see the other person as a full high quality 3D hologram, when it seems like that they're directly in the room with you. So you can recognize facial expressions and hand gestures. Getting a little bit more concrete, what kind of key performance indicators do we expect to see in 6G? Now, before looking at any of these, this is a reminder that these are part of a vision for 6G. Until the process of standardization is much further along, we can't make any promises because we simply don't yet know what frequencies we'll be able to use, nor which features will end up in which 3GPP releases. But looking at the vision, this is a diagram from Fraunhofer IIS, which is a large research institute in Germany. And green is what we expect to achieve in 5G, and blue is the vision for 6G. If we start at the top and the one to the left, we see a 10 times increase in the peak data rate and the user data rate, hoping to get to 1,000 gigabits per second peak rate and 1 gig for the user data rate. If we then go clockwise, we want to reduce the energy requirements to 1/2 of 5G. Then we're looking at much more precise localization, aiming for centimeter level accuracy or even millimeter level accuracy. Then the latency should be reduced to 1/10 of 5G, aiming for single-digit milliseconds. At the same time, we'd like to increase the density of devices by 1,000 times, especially to enable IoT applications that have millions of sensors. And we're looking to increase reliability by 100 times. But since you can reasonably expect a new generation to be faster and more powerful than the previous generation, I'd like to take a couple minutes remaining to look at a couple things that will be new or very much expanded in 6G. And the first new feature will be joint communication and sensing, also sometimes called integrated communication and sensing or network as a sensor. Now, what do we mean by that? We mean that the communication network will be augmented with features from radar networks, or the communications and radar will eventually merge into a single network. And this gives the communication network the ability to detect objects like radar currently does. So at the moment, the communication network knows the locations of objects that are actively part of the network. We know where cell phones are or robots that have SIM cards in them. However, when we add sensing to 6G, the communication network will also be able to detect objects that are not active in the network, such as buildings or trees or furniture. And this will enable applications that have a much better knowledge of the real physical environment around them. Another major change is a much better integration with non-terrestrial networks, such as satellite networks. This is also sometimes being called 3D networks, because the network will now not only span the surface of the Earth, it will also reach up into space. And integration with satellites, especially with constellations of low Earth orbit satellites, will let us provide much more coverage, especially in rural areas or, for example, over the oceans. And non-terrestrial networks also include drones for temporary coverage, such as during a natural catastrophe or when you have a large event like a music festival. Now, one of the main issues with satellite communications is the long latency. However, with low orbit satellites, the latency isn't as bad as you think, I promise, and it can compete with 4G. So yes, it's too slow for some applications that require extreme low latency, but it's good enough for many other applications. And last but not least, they're also looking at using direct satellite-to-satellite communication as part of the backhaul network, because light can travel faster in a vacuum in space than it can through fiber optics on land. And with that, my time is up. I'm looking forward to questions in the Q&A that's coming up. If you're at all interested in our activities as ThinkNet 6G, here's how you can contact us. All of our activities and events and workshops are free. Most of them are also online. You just need to sign up for our mailing list so you know when something's going on that you can attend. And to sign up for the mailing list, just send an email to that ThinkNet 6G address there and we'll sign you up. Thanks for now and see you in the Q&A.
Thank you, Kimberly. That was great presentation. I appreciate that. It was very insightful. So yeah, let's take a quick 10 minutes among all of the speakers and let's have a very quick, fresh Q&A on the latest development, or you have any questions from the presenters. Anyone can feel free to ask. Maybe I'll start up first. You see, the thing is that, okay, we know that the 5G development is so quick. We have a lot of new stuffs are coming in. We have these technologies, cloud, cloud architecture, what they call open RAN, private networks, new developments going on, so on and so forth. Now, the thing is that though the infrastructure are so greatly implied or deployed or have a good proper roadmaps, strategy deployments, the question is that do we have enough of innovative disruptors in terms of the applications? Because you see, at the end of the day, yes, it's all about consumer choice. The consumers are start experiencing the new stuffs that is been deployed, you know, whether from the Google Play Store or Apple Play Store, and all these new stuffs. But I just wanted to know, do you think that is there enough of innovative disruptors to cater such a need of 5G? We have started to talk about 6G, yeah, fantastic. But however, for the 5G, do we have the enough of applications to make, you know, hunger crunch of data? Because at the end of the day, it's all about the huge number of data and that can able to sustain the 5G deployment, right? So what's your opinion? Anyone wants to take this up?
I think it's a good question. I work with a lot of partners who try to, you know, find a killer use case to build their product around. And it depends if you're going after an enterprise market or an SMB market, right? I mean, it depends on the type of solution you're going to deliver. The video analytics seems to be quite a strong driver of a reason to put in a 5G network, but it's not the only way to do it, right? So it's not unique in its proposition. So I think that the use cases aren't as strong as they could be. You need to then kind of look at the overall business value and multiple use cases. So I haven't seen a single use case which says, I need to put in 5G because of this, and this is going to be what's going to drive everything. So I think it's a good question, and I haven't come across anything yet, to be honest. Single use case. Multiple, yes. Business value, yes. Some innovation across multiple areas, yes, but not a single use case.
Can I join in there and agree with Carl? Because we have a lot of discussions, especially about 5G private networks or campus networks. And exactly this question, why 5G when I've already got Wi-Fi or Bluetooth or whatever? And what we're seeing is a lot of so when someone decides to take 5G, it's often because of positioning and localization, but it's rarely enough. One use case isn't enough for a company to decide they're going to use 5G. They need to have 2 or 3 use cases before it's economically worthwhile to bother with 5G. Right. And probably, especially in this campus network area, there's not going to be so many companies that have multiple use cases at the same time.
Right. Can I know from any one of you, what is the average GB data per month that is being used in your respective countries? Like from Malaysia, it's about 6 GB per month.
I don't know.
No. Okay. Let me tell you that in South Korea, the average GB per data is being 27 GB. The highest, right? Globally. South Korea, because of the background of South Korea has been always in the front when it comes to the deployment of the latest technology since the 2G, 3G, 4G, and up to 5G. And they can able to spend billions upfront. They are not scared like other larger giant mobile operators. South Korea Telecom, they willingly to spend 10 billion USD without break even for the last 6-7 years. Not all other mobile operators are willing to do that, right? And they have tested out with a lot of gaming application, AR, VR stuffs, and the youths are really crunching those data. So I mean, when it comes to cloud gaming, of course, you'll be surprised. Saudi Arabia is one of the favorite when it comes to the gaming usage. So they are behind South Korea when it comes to the GB per month usage. They are already like surpassing like 23 or something like that, 23 GB. So these are the new things that is happening. Anyone wants to add or something?
Yeah, I just wanted to add that you just read my mind, because I was going to mention the e-games and e-sports is going to be probably one of the applications that is going to start with that. I also envision that the conferences will have the same thing, or concerts, as Kimberly mentioned it. Especially those are the cases that I feel like they have it. And also due to the isolation that network slicing provides, it will allow to protect this kind of gaming contest, because as you know, everyone can hack this, and many YouTubers, streamers, etc. have been competing already, and they couldn't participate in the end on the final track of the competition due to these hacks. So I feel like those will be the first ones coming, because it has already happened. So it's the direct approach. The trade-off will be that the quality of service, the isolation, and in my papers, if someone is interested into the details, can go through, but it's pretty technical, and I feel like this panel is also to be divulgative with all the people. So if they want to have a good search and read, I encourage that, and ask me if they need.
I would also
Can I also
like to.
Oh, sure, go ahead.
So thanks. I would like just to follow up on this. So why we see actually e-gaming, first of all, in 5G? Actually, we have e-gaming and we have in LTE as well. And the thing why we have e-gaming is that latency requirement is not like, for instance, for vehicle-to-vehicle communication. So you can have a great performance on e-gaming with the latency less than, for instance, 30 milliseconds, and that can be achieved in LTE as well. So that's the reason why we see that in 5G as well, because we have a much higher bandwidth of up to 100 megahertz in the mid-band range. So this is something that is on the first place. But then something that we need to let's say wait for is the useful applications with mobile edge computing. What will happen currently? MEC servers are mainly physical things, so commercial shell hardware. So we need to wait also for the virtualization to deploy these MEC servers on a as-per basis, and to put them as closer to the base station, so we can get like that end-to-end latency that will be less than 5 milliseconds, for instance. So this is just one comment from my side.
Yeah, thanks. I just wanted to also add that from a historical perspective, and also from the study of technology cycles, it's important for those of us that are more on the technological side to be wary of some of the pitfalls. So, we have a lot of technology to supply to the market, but we don't always know how to package it, or even what parts of the technology the market will find useful. So historically, you can look at the transition from 3G to 4G, for instance. There was a lot of money that was spent by operators to buy 3G mobile spectrum and so on, but it didn't really translate into commercial success. I think that came along more when 5G hit the scene. So we may see something similar, unless we actually learn some of those lessons from the past and say we should be a lot more agile, a lot more customer-centric, a lot more demand-driven than supply-driven. And I think pay attention to some of the scientific research on areas like technology cycles, which look at things like dominant designs, competence destroying and competence enhancing, technological disruptions. All of those things can play a role in what will eventually succeed in the marketplace. Thank you.
I totally agree with you, Doctor. Also, in terms of the BSS system, right, the business support, because billing is quite important and how we want to customize those packages. And it can't be on a traditional as what has been done previously, a fixed monthly rate or such kind of thing, right? And that's where, like, network slicing is coming in, and how we want to have those BSS customized together with the agile network slicing, because it based on the demand on various different customer segment requirements. Like each customer needs certain KPIs of speed and download capacity data and other so on and so forth requirements. So you have like not maybe more than hundreds of different packages. If that has been offered, then obviously it will attract more customers to pick and choose. Okay, this is really costly, or this is much more cheaper for me because I don't need 99.999 availability of KPI, right? I just need this amount of data and that's it. I'm happy with it. So yes, I think it's an end-to-end kind of ecosystem. That's how. I mean, it takes time to do the end-to-end, particularly the core network testing and all that stuff, together with the billing and all that stuff. Right? So, yeah, I hope the network slicing. Once the network slicing is ready, and I'm sure there's a lot more application can be tested out using the network slicing features.
Yep, actually, if I can add something else, I think also that the military service is using that, but of course we are not gonna know that because it's protected information, but for sure it will be paramount of important with these critical services that, in roads will be a network slice for the e-health reserved for them. And then if an accident happened, they will have the information faster and the car would be able to arrive faster, which is paramount when you are involved in health. They actually said always that one of the main things that come first to solve a problem in the public health is time. Just discover it in time, go there in time. So I think 5G will be also paramount there. Yeah.
Anything else?
I had a question for Dr. Ina, if that's okay. Do we have time?
Yes, please.
Yes, I wanted to ask Dr. Ina about telesurgery. What do you think, or where do you think are the areas where we could get to having real-time telesurgery? So I know you gave us a use case of consultation and then another operating team actually working on the patient. But how far away are we from a scenario where the doctor is in one place and the patient is somewhere else, and that doctor who is in the remote location is operating on the patient?
I think the most often situation will exactly this consultation during telesurgery, not when two doctors working together. But it's especially very good when it's one doctor young, another doctor much more experienced. It's for example, from our experience, doctor from London very often have consultation with their colleague in Dubai and Pakistan. And normally work between them, it's sent X-ray by email, and during surgery or before they talk by Skype. So it's not innovation in advanced approach, yeah. And when they use HoloLens, they can see in a real time what's going on. It's not only see X-ray; they can see holograms of damaged organ. At the same time, they can see video from patient inside the hologram and live video. So, and in this case, the experienced doctor can be much more useful for young doctor. And this is not once a day. It will be many times a day. It's very often. So when doctor will use exactly for at least for consultation during telesurgery, it will much more efficient for patient and for doctors too. I think it's a best way for right now, because if you will tell about exactly telesurgery with using, for example, Da Vinci, etc., and robotic, it's quite complicated. But of course, it's here now, but it's like a bit future now. I think it's a good step to start with consultation during telesurgery.
All right. So yeah, thank you so much. I don't want to take so long of your time. I really appreciate. I'm so grateful to all of you. I think we had a very successful conference today. Please take a couple of seconds for the audience to click the subscribe button of our YouTube channel. We will upload this conference within like 1 or 2 hours time. I mean, it's a small world. Let's keep in touch. Let's get connected. I really thank all of you. Thank you so much for your time today, and have a nice day. Thank you.
Thank you. You too.
Thank you. Bye-bye.
Have a nice day.
Bye-bye.
Bye.
Thanks. Bye, everyone.